What's up, party people, and welcome to Stone Toaster Gaming. I'm Brian, and today I'm taking you on a tour of something in the Oculus Quest, which I wouldn't call a game. It's more educational, but it is super dope. It is Titans of Space Plus, and today I'm going to use it to take you on a tour of the solar system. Prepare for blast off, astronauts. Let's go! Welcome to Titans of Space Plus, brought to you on the Oculus Quest for educational purposes. It's not a game, it's just educational, but it is totally cool. I wish you could experience it in 3D because in person it's really impressive. And it's made of a lot of actual visuals taken from space probes and probably the Hubble Space Telescope via NASA and mapped onto these different planets. So let's take a quick tour here. We are going to start, we're going to restart the short tour, which is just the primary planets and not most of the moons. And we start here with Earth. Welcome to Earth. So the distances are absolutely not to scale because obviously the sun does not fill our entire sky. But we are showing things fairly close to each other so you can get a sense of the scale of it as opposed to the distance between them. So let me grab that. So this is the relative size of the Earth to the moon. The moon would be much farther away. Also, if you take a look here, the sun is over there. And so what we're seeing is the shadow here. The shadow is where day turns to night. And as we rotate the Earth, so here's Africa. Africa is experiencing morning. The sun is rising on this line here. Now if we come to the other side, here's night side. In fact, there's the United States. There's us right there. And the moon is now in our sky. That's a full moon. So let me rotate back a little bit. So there's Chicago. And as I rotate forward, well, let's wait for the moon to pass. Hello, the moon. Now watch Chicago. Chicago is right there. As we go forward, it has now moved into the darkness. So on this line is where the sun sets for us. And as we move into the darkness there, now it's nighttime, and that's why all these little lights turn on. Those are artificial lights. Those are where major cities are. So that is how night and day works on all these different planets. So let's put the Earth back, and let's continue. Welcome to Mercury, everybody. Mercury is the closest planet to the sun. Again, the distances are not to scale, but just to show you the size of the sun, it looks enormous from in here. I hope it comes across on video, but let me show you. Here's Mercury. So this is made of pictures that various spacecraft have taken over the years, and it looks a lot like our moon. It's gray, it's dull, it's got a lot of impact craters from being hit by stuff throughout the years. It is the smallest planet in the solar system. Now, one of the great things about this program is it lets you compare the size of things. So that's Mercury. I'm not going to put it next to the Earth. So now you can see the relative sizes there. So there's Mercury, and here's the Earth. So that's what they would look like next to each other. Mercury is significantly smaller than the Earth. Now let me put it next to the moon. So it's a little bit bigger than the moon, but not by a whole lot. As you can see, relatively close in size there. All right, moving on. So as we approach Venus, you can see there's no real features to be observed because there's just an enormous cloud cover all of the time. We cannot see the surface of Venus. Mercury has really no discernible atmosphere, so there's nothing but surface to be seen. So Venus is fairly close in size to the Earth. Let me put those next to each other so you can see. They're very, very similar in diameter. So Venus is just slightly smaller, but they're very, very close. And Venus is the most similar in size to the Earth. So it's very, very hot on the surface of Venus. Let me see if I can pull up some pictures of that here. All right, so we have been able to use different technologies to see the surface of Venus, and it does seem, again, to be very rocky. And it seems like there might be geological activity, maybe volcanoes happening there. This is a very close picture of the ground. So on the bottom here, you see the site of a Russian space probe that landed. So this is the surface taken from the surface. So this spacecraft landed in 1981. It took a couple of pictures and then immediately started to fall apart because the temperatures are so extreme that nothing can survive there. Let me see if I have... There we go. Average temperature is 863 degrees Fahrenheit. That that is absurdly hot. But again, they think that the reason why it's so hot is because it's covered in this enormous cloud cover, and that just traps the heat and doesn't let it escape. So Earth and Venus are very similar in a lot of ways, but that difference makes all the difference. Let's head on to Mars. Again, keep in mind that distances are absolutely not to scale. The purpose of this program is just to show you the size differences between these different objects. We've arrived at Mars, the red planet. There you go. So there's Phobos. There's one of the moons of Mars. It has two different moons, and they're both very, very tiny. Where's the other one? There it is. Deimos. So compared to our moon, the size difference between Mars and its moons is a huge difference. Whereas our moon is the closest in size to the planet it orbits compared to any other moon in the solar system. Every other planet and moon combination, the moon is far, far smaller. The moon is about the width of the United States, and so it's roughly a fifth the size of the Earth. Whereas, as you can see, the moons orbiting Mars here are these tiny little pebbles. So let's take a look at the size comparison between Earth and Mars. So as you can see, the size difference between Earth and Mars is not enormous, but it is fairly significant. I mean, just in terms of sheer size, the Earth is not quite twice the size, but it is significantly larger. But again, compared to the moon, Mars is significantly larger than the moon. So there's our moon, and there's Mars. So Mars is a sizable place, and essentially, if you take away all the oceans, the amount of land on Mars would be about the same as the amount of land on Earth if Earth didn't have, or if you don't factor in the oceans. But of course, because the Earth has oceans, that there's a huge amount of space that the oceans take up. So there's a lot more land, there's a lot more surface area on Earth, even though there's not a lot more land surface. Most of the Earth is underwater. Anyway, back to Mars. Let's get out of here. Let me take you on a quick tour of Mars. Mars is fascinating because it has a lot of interesting features. Here, this scar right here is like the Grand Canyon of Mars. It is probably the biggest canyon in the solar system, or one thereof. It's enormous in depth, many miles wide, many miles deep. But more than that, there are these volcanoes. Let's see. There's a lot of cratering. Different types of rock. Primarily, the reason why Mars is this color is because of iron oxide, or what we commonly call rust. So there's enough iron on the surface that interacted with oxygen, or perhaps was created already oxidized. We don't know because we did not see it before we had telescopes. But that's what gives it that reddish color, is essentially a sandy dust covering. So this right here, I believe, is Olympus Mons. It is the widest, largest, tallest volcano in the solar system. Not active though, dormant as far as we can tell. These volcanoes are all dormant, just sleeping on Mars. But some of these features, again, very, very high, or very deep. So some have surmised that there was once water on Mars, and people constantly say, well, we found water on Mars, They have not actually found water on Mars. They have found features that they think indicate either water was or perhaps still is on Mars. The poles, North Pole here, that is not water ice, that's dry ice. So the atmosphere is mostly carbon dioxide, and it freezes at the North and South Pole, and you get these little chunks of dry ice, and you find those sometimes other parts around the planet. And that might be one of the reasons why there's different geological features, is because as the dry ice freezes and then sublimates, it moves around, it causes geological features, it causes weathering. And there's a lot of wind. It's very cold and very windy on Mars. There's a very thin atmosphere. In a lot of ways, it's like Antarctica is, where it's similar in temperature and similar in the fact that there's no precipitation. There is high winds. There's just a much thinner atmosphere. So while we dream of living on Mars someday, there's a series of problems to overcome. It's actually going to be much easier to set up shop on the moon, not just because it's nearby, but for a variety of other reasons. Anyway, Mars. Let's move on. It is the largest planet in the solar system. It is 5 times farther away from the sun than Earth is. And so, again, the sun is just created here to give you a sense of scale between the size of Jupiter, the size of the Earth, the size of the planets. But from Jupiter, the sun would look very, very small. It would appear as the brightest star in the sky, but it would not be nearly this encroaching. So, again, let's take a look at relative sizes here. Let's put Earth up next to it. There's the Earth next to Jupiter. As you can see, many Earths could fit inside of Jupiter if it were hollow. The Earth is a smaller rocky planet. Jupiter is just the most massive planet in the solar system. All right, let's roll this thing over till we can find the great red spot. Where'd it go? There's a lot of swirling storms on these cloud bands. So all of this is just atmospheric clouds and storms, and there are different tornadoes and hurricanes, giant, massive ones. But the most famous is the great red spot. There it is. The great red spot is almost 3 times wider than the Earth. So if we were to put the Earth back up there, let's see. You can see that's the size of the Earth. That great red spot is nearly 3 times wider, and as far as we can tell, it's been there for 300 or 400 years. So there's been fluctuations in it. It seems sometimes like it's going to go away, but it's still there. So according to this, Jupiter is made mostly of molecular hydrogen in a gas, liquid, and metallic form. Because a strange thing about different substances is under different amounts of pressure, they change their state. Hydrogen is primarily a gas, but under the right circumstances, under the right amount of pressure, it can become metallic, somewhat of a solid. So here's some pictures taken by Juno, the space probe. A lot of great pictures have come back from Jupiter. Let me just grab it. So there's a lot of interesting storm systems at the North Pole and South Pole. And again, just swirling hurricanes at every level. So the great red spot is its most recognizable feature, but it's got these stripes. It's sort of the striped Halloween pumpkin of the solar system. And lots of hurricanes, lots of action. It's also got a shorter day than we have. The entire planet rotates once every 10 hours. So a day on Jupiter is shorter than a day on Earth, even though it's that much bigger. So a lot of energy, a lot of activity. And again, the most mass of any object in the solar system other than the sun itself. Let's go see the jewel, Saturn. Again, Jupiter is a gas giant, so it doesn't have a surface. If you took a rocket ship to Jupiter, you couldn't land there. There's no surface to stand on. It's just gas, clouds, all the way down until at some point the pressure becomes so great that it probably turns into a liquid, and maybe at the core even solidifies some. But again, there's nowhere to stand. Now again, much, much farther away than this. Oh, well, hold on. You can see, from here you can kind of see the rings. So again, Jupiter has a thin series of rings around it, which are hard to see. But of course, when you're talking rings, you're talking Saturn. So Saturn has this enormous collection of rings that span for many, many, many miles, thousands of miles. But they're very, very thin comparatively. So the width of the rings compared to the thickness of the rings means that the rings are essentially thinner than a sheet of paper. Which means that when you're looking at it, when it's tilted this way, it's easy to see from Earth in a telescope. But if Earth is on the axis like this, the rings become impossible to see, but sometimes they cast a shadow to let you know they're still there. So the rings are not easy to see all of the time. They have to be sort of tilted toward you or away from you in that sense. There's many different individual rings of different thicknesses, and the rings are not a solid object. The rings are essentially just billions and billions and billions of tiny moons. They're made up of little rocks, dust and ice. The rings are made out of tiny comparatively. They're made out of things the size of a grain of sand, or potentially boulders, maybe a couple of miles across, but even at this scale, that's just nothing. So all these rings are is just organized collections of rocks and dust, and sometimes organized by the moons that travel within them. Saturn has a wide collection of rings with moons outside and inside them. And here's some pictures of what the planet looks like up close from satellites. You can see, even up close, the rings are so big that it's still impossible to distinguish the different particles that make them up. Let me get to, all right, here we go. This is Daphnis. So there are what's called shepherd moons, and those moons travel in these gaps and sort of keep them organized. There are moons whose gravitational pull causes these rings to stay organized and clean. They're sort of a cleanup crew. Interestingly, though, there's also a couple of moons that cause, and you can't see it at this scale or on this model, but there are some moons that cause some of these rings to be braided. So it's not just a cleanup crew, but it's design and beauty. Now, one of the interesting features about Saturn here is this. The poles are kind of hexagonal. So let me show you that on here again. Okay, that's a little hard to see on here, but for some reason there becomes this sort of straight line pattern that shows up at the poles. Let me see if it's on the South Pole. No, it's the North Pole. So this is based on photographic imagery from satellites. It forms this kind of straight line edge, which you didn't see on Jupiter. On Jupiter, this sort of more swirled into obscurity, but here it sort of hits a place where there's a line, and nobody's really sure why, but there's that hexagonal shape at the top of the planet. That is not a mistake. That's what it looks like. So the planet itself is kind of like Jupiter in the sense that there are bands of different colored clouds. They're just a little fainter, a little harder to see, but it doesn't need anything flashy when it's got these rings. So just to make sure I do this, let's go and bring the Earth in there. And as you can see, the Earth is, again, much, much smaller than the gas giants out here in the outer solar system. So that's what Earth would look like sitting next to Saturn. And yet, even still, the distance between the Earth and Moon is so great that you could put all of the other planets between the Earth and the Moon. So if Saturn was between the Earth and the Moon, it would have plenty of space for those rings. Interesting. All right, let's move on. Oh man. If you ever have a chance to do this, to put on the Oculus Quest and see this from the inside, I do recommend it. The little spaceship makes it easier to deal with while you're flying through space, but the view is just astounding. And there's that pole feature again. That's all made of clouds. You can see how thin the rings are as we pass underneath them. At some point, we're right on the edge of it and they just disappear because they're so thin compared to their width. Welcome to Uranus. I like to pronounce it the Swedish way, Uranus. Now, this is one of the two ice giants out here in the outer edge of the gas giants. So these are tremendously far away. It's 19 times farther away from the sun than we are. The interesting thing about this planet is you can see it's got rings, but instead of being north-south like this so that it faces the sun and rotates into the sun like every other planet, the North Pole is right now pointed at the sun. So its pole runs this way. And as it rotates, well, the north half of the planet is in summer essentially having daytime for the entire time. And all of this in the back is constantly in the darkness. So that the northern hemisphere right now is having daytime and the southern hemisphere is having nighttime. And then of course when it travels, as it travels, it's facing the same way, so that on the other side of the sun, the South Pole would be facing the sun, and the north side would be in the dark all the time. We'd be having nighttime. So that is the weird, interesting thing about it, is it seems like this is a normal planet that got knocked over on its side, so now it's just rolling around the solar system. So again, this is smaller than the other two gas giants, but when you put Earth next to it, you can see it is still a gas giant. It is an enormous planet, takes up a lot of space, It has a lot of high winds, and because it's so far away, there's not a whole lot we know about it. So that's what Earth would look like sitting next to Uranus. You could put 63 Earths inside, but you wouldn't want to. So its orbit is 84 Earth years long. So one year is essentially what the amount of time it takes something to orbit the sun once. So our year is 365 of our days, technically 364 and a quarter. So this planet orbits around the sun once in 84 of our years. So every planet has its own orbital year, that their year lasts a different amount of time compared to ours. So because of better telescopes being put into orbit, we have been able to photograph it from space and through telescopes. So we haven't only seen it through satellite imagery, but the satellites we've sent here, Voyager 1 and 2, got a good look at the at the outer planets, and that's why we have the images that we do for the most part. But again, because the clouds move so fast, and because they're all very similar in composition, they're not as distinct as they are on Jupiter. Jupiter is very distinct in that sense. All right, let's take a look at the last one. It is called Neptune, and it's very similar to Uranus. This one is just funny that it's fallen over sideways. Why is it sideways? So again, some tremendously interesting ring structures, not as dense as the ones around Saturn, but still just fascinating that all these billions of tiny particles orbit in these very distinct rings, and again, probably shepherded, kept in their distinct rings by other moons that are orbiting, because all these gas giants have a collection of moons each. So I'm not showing you all the moons, I'm just showing you the planets. And we have made it to the last of the gas giants, Neptune. So let me bring up first the Earth, so you can see the size difference. Again, there's a whole lot more Neptune than there is of Earth, but let's see if I can't bring, there you go. So as you can see, Uranus and Neptune are very similar in size. I mean, a difference of just a couple percent here. So very similar in size, kind of similar in color. Let me bring Earth up again. So the inner planets, Earth, I mean, again, Mars, much smaller. There's our moon, there's Mercury, Venus. All of those rocky planets in the inner solar system could fit inside one of these gas giants easily. So there's Neptune. It's got some large moons. It's got its own faint reddish ring structure. I don't know if you can see the rings, they're reddish. And their color comes from their chemical composition. So sometimes we can make out clouds, but it seems that the clouds are going to change on Neptune faster than anywhere else because it has the highest winds of anywhere in the solar system. Great dark spot. So again, there's clouds, again, giant hurricanes, larger than Earth itself, similar to the one on Jupiter, just not as long lasting. So highest wind speeds in the solar system, 2,100 kilometers per hour. So if we were to build a city on Neptune, it would be wiped out by winds immediately. Now, of course, we can't build a city on Neptune because there's no land to build it on. The gas giants, again, don't have a solid surface to put anything on. Thus, gas giants. All right, let's pick this up and take a look at it. Again, this thin reddish ring that goes around it. We have features like, kind of like the great red spot on Jupiter, but darker. And again, the outer planets don't seem to have storms that last as long. That red spot, existing for 400 years, still remains kind of a mystery, but a fascinating one. Kind of see the rings there. So the outer planets have rings, which are essentially a huge collection of tiny moons. And they also have larger moons, which we will look at sometime in the not too distant future. So we got one more stop here. We are done with the gas giants. Let's take a look at our tiny friend in the outer solar system. The one that used to be a planet is now a dwarf planet, or I don't know. Depends who you talk to. In my heart, Pluto will always be a planet. The thing I always forget, though, is it named after Mickey's dog, or is Mickey's dog named after it? I can never remember. Why would you name a dog after a planet? But then why would you name a planet after a dog? I don't know. Welcome to the Pluto system. There's Pluto with its moons Charon, Nix, and Styx, and Kerberos and Hydra. Hydra, that's that thing that Captain America's always fighting. I guess he threw it out here. Eris is another dwarf planet. So again, you get these different things of different sizes, and you get something orbiting something, so that's a moon, but then it's got something orbiting it, and they all kind of dance around some center point of gravity. So unlike the other planetary planet-moon systems farther into the solar system, this one just gets to be things orbiting around a common gravitational point. So is it really right to call it a planet and a moon? So there's debate. The point is, it used to be a planet, now it's on a dwarf planet. So this down here, this we just discovered a couple years ago because we finally got satellite imagery. For the longest time, we had no idea what Pluto looked like because we didn't have a telescope that could see it. And so we assumed it looked like Mercury. But then we got here and saw that it's got these different color rocks, different types of mountain ranges, and this, I don't know if you can see, it looks kind of like a heart. So it's different kinds of geographic material, and it looks kind of like a heart. It's a little Valentine out there. Now, what I appreciate about this is that these question marks tell you that we don't have pictures of this side of the planet. So that'll be true of a bunch of the moons in this game too, or application I should say. It's not really a game, but they don't put imagery where there wasn't any from satellites or from telescopes. So similarly, this one too, we don't know what the back of it looked like because when the satellite flew past this, the New Horizons probe flew past in 2015, so really pretty recently. We were only able to see one side of it because it didn't stop in orbit and take lots of pictures. So Eris over there is a similar system. These things, again, are very, very small. Let me pull up the Earth here. So as you can see, there's the Pluto system, and here's the Earth. The Earth takes up a whole lot more space. Let's just compare it to the Moon. The Moon is slightly larger than Pluto. So if we replaced our Moon with Pluto, it would take up less space in the sky at the same distance. So there you go. The tiny Pluto. Boom! Titans of Space Plus. You get to tour the solar system. What I've shown you there is just a little bit of what's available. There's another section where it compares some of the largest stars we know to our own sun. There's a guided tour through the entire solar system, including a lot of the different moons that you'll find and a couple of the larger asteroids. So there's a lot more content than I've shown you here. I think it's totally worth it. This is one of my favorite educational games for Oculus Quest. Check it out, and if you've seen it, let me know what you think down in the doobly-doo below. I'm Brian, this is Stone Toaster Gaming. Game on, my friends, and I will see you in the future.